I'm going to show you the circuit that I would like you to build for project number 1. Notice the orientation of our board. The photon is pointing towards the right. The USB connector is pointing towards the right. And we have taken the ground line with this black cable, and we have put a copy of the ground line in all of the blue connectors on the bottom, and also taken another black cable and put a copy of our ground in all of the blue connectors on the top. Additionally, we have taken the 3.3 volt signal and put a copy of that on the top, on the red line. We have not put a copy of the 3.3 volt signal on the bottom. The circuit consists of 4 switches. Switch 0, 1, 2, and 3. 4 10 kilo ohm resistors, 1, 2, 3, and 4. Let me move the cable so you can see the 4th resistor right there. 3 LEDs, LED 0, 1, and 2. And 3 510 ohm resistors, 1, 2, and 3. Let me explain a little bit how the switches here operate. These are push button switches. And when you push the button, what's going to happen is that you're going to join the 2 top terminals with the 2 bottom terminals. Notice that the terminals can be distinguished on the top by these black dots. When the switch is not pressed or the button is released, the 2 terminals on the bottom are going to be 1, and the 2 terminals on the top are going to be 1, but they're not going to be joined. So again, when you press the button, you're going to join the 2 top terminals with the 2 bottom terminals. This switch is connected in the same way as the example that we looked at in class. Notice that the bottom terminal is connected with a resistor to ground, and the top terminal right now is connected with this green cable to D0, and with this orange cable, is connected to VCC. When we press the button, what's going to happen is that VCC, or the 3.3 signal coming through our orange cable, is going to be applied to the top terminals, and it's going to be copied with the switch pressed to the resistor and then going to ground. In other words, when we press the button, we're going to generate a logical 1 and read that logical 1 with the green cable and input V0 right here. The other switches, this one, switch number 1, is going to be connected to D1 using the brown cable. This one right here, switch number 2, is going to be connected to D2 using the blue cable. Switch number 3 is going to be connected to D3 using the white cable. Naturally, you don't have to use the same colors or the same type of cables. On the top we have the LEDs. Each of the LEDs is connected to ground via a resistor. The cathode is connected to ground. Now, the other side of the LED is connected to either D4, D5, or D6. So LED 0 is connected to D4 with this yellow cable. LED 1 is connected to D5 with the red cable, and LED 2 is going to be connected to D6, in this case with a white cable. And that's the circuit. So how does this circuit operate? Whenever I press switch 0, 1, or 2, I'm going to change the state of the LEDs, 0, 1, and 2. So if I press switch 0, LED number 0 starts blinking. If I press it again, it stops blinking. Notice that on the video you might not be able to see the LED blinking due to the capture rate of our camera that I'm using here. So if I press switch 1, I'm going to make LED 1 blink. If I press switch 2, I'm going to make LED 2 blink. If I press switch 0, I'm going to make LED 0 blink. If I press any of these again in any order, I'm just going to switch them back to off. Now notice that we have our 4th switch, which we call switch 3 here, and we're going to use this one is to change the blink rate of our circuit. So let's turn on LED 0. Notice that it is blinking really fast. On the video you might actually see it as permanently on, but it is blinking really fast right now. And if I press switch number 3, remember 0, 1, 2, 3, or the rightmost one, is going to change the blink rate. Right now it went from really fast to what I'm going to call slow blinking. I'm going to press it again, and it's going to change from slow blinking to medium blinking. Again, this state might not be easily viewable on the video. And if I do it again, it's going to go to blinking very fast. Now, let me turn off. Remember, right now it's blinking very fast. Let me turn off that switch, that LED, excuse me, by pressing switch 0. And I'm going to press this once. So that should also change the blink rate, even though the LED was off. Let's see. Yes, indeed. Now it is blinking at a different rate, and I can keep changing the rate as well. And I can do the same for any of the other switches. Right now these two are on and blinking. I can press the switch number 3 and change the blink rate of these two that are on. Even if they're off, I can change the rate. And also notice that the switches blink independently. So right now, the LED blink independently. LED 0 is not blinking at the same time as LED 1, as LED 2, even though all of those are blinking at the same rate. So the same time on and the same time off, they're just doing it at different times. So notice that it is possible, or it is, the software allows you to turn them off at any time. So notice right now they're blinking at the same rate, but at different times. And that's the circuit that you're going to be building for project number 0. Now there's an optional part for those students in ITS 5900, and is to use switch number 0 as a programming button, so that if you press switch number 0 for a long time, a few seconds for instance, you can actually change the blinking rate of our LEDs by pressing switch number 1 and 2. Switch number 1 to make it go slower, switch number 1 and 2 to make it blink faster. In that mode, switch number 4 will not play any role. I'll post the details about the optional part along with the project description on Blackboard.